This is Unit 4.2. We start with a quick review of triangle sum theorem. For some reason that all students really love this because it's an easy theorem to remember. All it says is that given any triangle, you add the angle measure of the interior angles. So the angle measure for A, B, C, you add it together. You have a magic number at 180 degrees. So that's very familiar to all of us. The next one is a new one. It's called exterior angle. First of all, I should have stressed that from this chapter onwards, we're studying triangles. So what's an exterior angle for a triangle? We have a couple. Basically, anytime you extend, let me see if I can use a different color. I'll use red. You extend one line and look at this angle 1 here. That's one exterior angle. And if I use a different color, if I extend another side of a triangle, I can call that angle 4, right? And if I use, let me use another color, let me use purple. So if I extend angle 1, angle, one of the sides here, and there, I can call that angle 5. So angle 1, angle 4, and angle 5, they're all exterior angles. And just to make life a little easier for us to see, you can see that the exterior angle theorem states that any exterior angle is always equals to the sum of the two non-adjacent interior angles right there. So what does that mean? It means angle 1 equals the measure of angle 2 plus angle 3. In fact, see if you can use substitution to prove this theorem from the first one that we just reviewed, triangle sum theorem, to prove exterior angle theorem. So next, let's look at some of the problems below. They're fairly easy. A lot of you have done this before. So here we're asked to find all missing angles. For number 1, angle measure 1 should be just 180 minus the other 2. And you should have 119 degrees. That's based on the triangle sum theorem. And number 2, notice that I have an exterior angle, and exterior angle theorem says angle 1 should equal the sum of the two non-adjacent interior angles. So that should be 128 degrees. Okay, same thing with number 3. Let's look at some of the harder ones. Number 4, where should I start? Probably the easiest is number 1. Number 1 should be 180 minus 66 minus 84 based on triangle sum theorem. So that's angle 1. And angle 3 and that 84 degree probably is the easier one to see. That's obviously a linear pair. Therefore, angle 3 is 180 minus 84 because they're linear pairs. And that answer is 96 degrees. Angle 2, is not easy to, it's not hard to find it in the second triangle. See if I can draw this with purple. I've got a second triangle here, and I have angle 2 plus angle 3 plus 43 degrees should be 180 degrees. So the final answer for that one should be 41 degrees, since I know angle 3 is 96 degrees there. Okay? So that's problem number 4. I'm gonna finish number 5 and number 6 on your own. Notice that number 6, we've got a vertical angle there. And then number 7, I'm gonna do it with you. So make sure you pause the video and finish the other 2 and then come back to number 7. So number 7, the hints we're given is BC bisects ACD. So BC is here, which means that if it bisects ACD, that means angle 2 and angle 3 are exactly the same. Also notice what's not written in words, but it's provided here is ACD is 90 degrees. So obviously 2 and 3 are 45 each, because an angle bisector, bisects means to cut something in half equally, right? So if I have 45 degrees here, in triangle ABC, I know that angle 1, 48 and 45 degrees adds up to 180. So that should be 87 degrees. And in triangle BCD, I know angle 4, 83 degrees, and 45 degrees for angle 3 adds up to 182. So if I do my algebra there, I should have 54 degrees. So those are some basic practices. In the next page, there are some more challenging ones that we'll use, especially I'm looking at number 9, that will use parallel lines and some other information that we have learned already. So let's do some of these. Let's start with number 9. All of you are really good with this by now, so I'll just get right into it. See what I can get from the given information. If L and M, line L and line M are parallel, angle 1 and this 73 degrees are based on this transversal, they are alternate interior, so they must be congruent. So I've got number 1 there. And same thing with, let me see if I can make this a little smaller. Oops, sorry. Same thing with angle 4 and 49 degrees, right? So that should be, so angle 4 should be 49 degrees because they're alternate interiors angles as well. And if I have, let's look at angle 3. Angle 3 and 73 degrees obviously are a linear pair, so angle 3 must be 180 minus 73 gives me 107 degrees. And then if I want to use triangle sum theorem to solve for 2, I can do that. That's probably not very good. I want to do it so that you can see. Use a highlighter. There we go. So that should angle 2 plus 73 degrees plus angle 4, I should have 180. Therefore, if I subtract that, I should have 58 degrees. Okay, and then angle 5 and angle 4 obviously are linear pair as well, so that's 131 degrees. So that's how you use the parallel lines and what we learned in chapter 3 of those relationships to help you solve this problem. I'm going to leave the rest of it for yourself. And let's look at the next section. Solve for x, then find each angle measure. Basically, it's still the same thing. You find the relationships, you try to establish an equation, and you solve for x, and then you plug the x back in to solve for the final answers. So let's see how we do that. We're given 3 angles here, angle DEF, and they're all interior angles. Other than that, we don't have much other information. So the good thing is that we only have one variable. So if we take the first angle measure, then we take the second angle measure, make sure that you copy it correctly. And then you take the third angle measure, you add them together, you should have 180 degrees based on triangle sum theorem. And if you do your algebra right, I am doing some mental math here, so that should be 25x minus 20 equals 180. and therefore I should have about x equals, not about, x equals 8, right? So once I find out x equals 8, I simply plug it back into this and then solve for my angle D should be 38 degrees. Angle E, the measure should be 75, I think. And then the last one is 67 degrees. So those problems look more complicated because of the variables, but what doesn't change is the relationships of these angles, whether it's triangle sum theorem or exterior angle theorem, or using the parallel lines and to find the 4 pairs of angles that we talked about, or vertical angles or linear pair. Those are the tools that you can rely on, and you go back to them again and again and again. Oops, I think this is, there we go. Let's look at so pause the video, finish everything in there, and then let's look at number 14. And over here, I'm given this angle and this angle and then this angle. So I have 2 interior angles and 1 exterior angles. I have to use the exterior angle theorem, which says the angle measure for the exterior angle is the sum of the 2 non-adjacent. Question, why is it non-adjacent? Why does it have to be non-adjacent? What happens if it's adjacent? What happens if it's adjacent? Notice adjacent is the linear pair, right? So that's why it has to be the non-adjacent. The adjacent have a different relationship. So if you solve your x should come out to be 5. That's right. And then you plug the x back into the angle A, angle B, and all the others. So let's see, angle CAB is 13x minus 11, so 65 minus 11, that's 54 degrees. Angle ABC, plug it in, you should have 21 degrees. Angle ACB, there are 2 ways of doing it. You can use 180 minus 54 minus 21 using the triangle sum theorem. Or you can find angle DCB first, which is 75 degrees, and then use linear pair, use 180 minus 75. You will get to the same answer at 105. Okay, so make sure you finish the packet and bring your questions back to the class.